Hi everyone, this is Mahesh and this is a continuation of the previous video, where in the previous video we saw how efficiency matters and how a single solution implemented using different algorithm results in different execution time. So in this video again we will see how the data structure, selection of a data structure to solve a particular problem results in efficiency. Let us try to understand what is data structure. So data structure is basically the way we store the data, which we saw in the previous video. And it is not only the way we store the data, but the data should be efficiently used. So let us consider the queue implementation for an instance in this video. So basically what exactly is a queue? Queue is a FIFO model. So FIFO model in the sense the first in first out model. So basically if we consider this as a queue and let consider few blocks, and if we want to insert something, then we will insert something at the end. Then if we want to remove something from this queue, then we want to get it from the other end. So basically this we can call this is end and this is start of the queue. So basically this is a queue data structure. So now we want to implement this queue using different the fundamental data structures that are available. Maybe we will see two examples, one using array and another using linked list. So now let us take an example of array. So array, it is a representation of block of elements where we keep on adding elements into the array and which will be appended at the end of the array. So once the array is empty, once we try to insert something, it will insert here, then here, then here, then here, and then here. Now assume we want to take out something from this element, so we can pop something out of this array which is from the end of the array, but that is not the case for our queue data structure. We want to take the first inserted element which is from this side. So if that is the case, if it was taking out the element from the end, then we could have done in one operation. But that is not the case here. We want to take it from the other end, the starting of the array. So if that is the case, then if we take this element from here, then we have to move this element and then this to here and this to here and this to here. That way we will end up doing n number of operations. So what exactly is this n number of operations? N is nothing but the number of blocks or the number of items that are present in the array. So if that is the case, for mq operation, it takes order of one time because we can simply append the element at the end. But for dq operation, it is of order n, so it takes n number of operations. Now so this is what we get if we use array to implement the queue data structures. Let us consider a linked list. So what is linked list? Basically linked list is a block, it is a list of nodes which points to each other. Say for example we have two elements, so it will have the value and a link to the next value, something like this. It will contain value 1 and it will be linking to the next element. This contains value 2, it contains the link to next element, and so on. And this linked list contains a head pointer which points to the start of the list and a tail pointer which points at the end of the list. Now in this case, if we want to insert an element at the end, what we will do, we will simply add the node and we will link this to this, and we will remove the tail pointer and we will simply map it here. Now if you want to take out the other element from the other end, so we will simply take out and we will simply point head pointer here. So in this case, what we understand, both NQ and DQ operations, they are of order one time. They are of order one time. So if we compare both, if we use array to implement a queue, then it will take order of one time for NQ, but for DQ it takes order of n time. In the similar fashion, if we take a linked list, then it will take order of one time for both NQ and DQ operation. So which one is better for the queue data structure? So basically linked list will be a better option for queue data structure. Yeah, so with this understanding, so efficiency does matter, and efficiency comes with choosing the right data structure. And this DSA, it will enable the algorithmic thinking of the developer, and thus developer will break the solution for a complicated problem in a better way if his algorithmic thinking is good. And this DSA will give the raw, it gives the ability to solve a particular problem in a raw way. We don't specify any language when we say, we are trying to solve a particular problem here. Yeah, with that, we understood that how algorithms, choosing a better algorithm and choosing a better data structure will solve a particular problem efficiently. So if we are good in both, then we are a good fit for these product-based companies. That's why they concentrate more on DSA understanding of a developer. That's it for this video. Thanks for watching the video.